Good morning, everybody. Hope everyone's had a nice weekend. Finally had some good weather on Saturday. Today we're going to go over page 215 and 216 in your note packets. We're going to talk about half-lives and how to go through the half-lives if they changed the units on us. Okay, so first on page 215 here, they're talking about the decay rate of carbon-14. Now, what makes half-lives and radioactive dating very reliable is that these half-lives remain the same. There's no outside conditions that can speed them up or slow them down. Okay, mass, volume, temperature do not play a role in the half-life of an isotope. So carbon-14 decays at a rate of 5,730 years, and that rate is consistent amongst all the carbon-14 atoms and isotopes there are out there. Okay, so in this diagram here, they're displaying the half-life of C14 using pie graphs. Okay, in the first original sample, you have 100% carbon-14 in here. Okay, it hasn't decayed yet. And then when we go to the second sample, this would represent one half-life. You have 50% carbon-14, and then it decayed into 50% of the nitrogen-14. So that would represent one half-life. Carbon-14 we would use on any organic remains, so a bone, a tree trunk, anything like that. So imagine, you were digging in a site and studying something, and you come across a bone, and you measure 50% nitrogen-14, and you saw the ratio to 50% carbon-14, you would be able to then state that age of the bone is 5,730 years, because that's the amount of time it took to go through one half-life. The second half-life, you take half of the carbon-14, you convert it over, so now you have 75% nitrogen-14 and 25% carbon-14. Notice one thing, through each half-life, the total is always 100%. Okay, and then the last one here is 87.5% to 12.5%. And this would be your third half-life. Okay, now carbon-14 is something that we would not use to date the age of the Earth. We would use a different isotope to date the age of the Earth. We would use uranium-238 because that has a half-life of 4.5 billion years. Okay, some objects we might date with uranium-238 would be moon rocks, meteorites, objects from space, and some of the older rocks or oldest rocks here on Earth. Now on page 216, what we got here is we're not going to always just happen to work with percentage. Okay, so we have 0 half-lives, and instead of putting a percent here, I have 400 grams of potassium-40, and at 0 half-lives, that means none of it would change over, so I'd have 0 grams of the calcium-40, and no years have gone by. But at the first half-life, we would have 200 grams of the potassium-40. I have to put that there. And we would have 200 grams of the calcium-40. So we would have a 50-50 ratio. At the third half-life, right, we would take half of the 200, so we would be down to 100 grams. And then we would have to take that and put this over here. We would have 300 grams. Okay. Notice that the total between the columns always equals the original amount of 400 grams. Okay, and I'm going to leave column 3 for you guys to do on your own. Okay, for the years, I'm going to leave that for you guys as well. We looked that up on the Earth Science reference table, and then we just keep doubling the years as we go down. All right. In the second example, we're going to use percentages. So remember, in the beginning, we always start out with 100% uranium-238 or whatever the isotope is. And at 0 half-life, you would have 0% of the other. Okay. And then the final one here on page 216, we're using symbols. So you actually got to count up the uranium-238 symbol here. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 16 uranium-238s at 1 half-life. You would have 8 of them, so you would draw 8 circles, and then you would have 8 of the lead-206, so there would be 8 slashes. And then at the second half-life, right, you would decrease the uranium-238 by half and increase the lead-206 by whatever you took away from the uranium. Okay, so that's how you do these 2 pages. If you have any questions, feel free to message me, and we'll meet later on in the week. Have a nice day.